to this computer. Okay, so question 27. Okay, so everyone have a quick read of this. The idea is we've got however many pop sticks we want, but we only have 5 different colors to choose from. And the question is, how many distinct triangles can we make with different colors where a triangle is considered the same as another triangle if we rotate or flip it? Okay, so I'm just going to show how I did this. Again, there are different ways to think about this, but I'm going to split this up into 3 cases because, again, we want to count systematically. Sorry, Hugo, for ignoring the 1, 2, 3, 4, 5 labeling. If that helps everyone, then go for it. But yeah, this is just how I did it. So, oh wait, why have I done this? Okay, so case 1 is that we've got 3 sides of the triangle the same. So I'm just going to denote that as A to indicate that all sides of the triangle are color A. Sorry, Hugo. Now for the second case, it's where we have 1 color and 2 of the same other color. And for the final case, it's where we have all different colors, so A, B, C. Now, I want everyone to understand that, I want everyone to understand that these cases are all distinct from each other, so they don't overlap, and that's obvious because, well, they are very different cases, and I'm not going to be counting, I'm not going to be over counting. But I also want to understand, I want everyone to understand that I've also counted everything. So, for example, with the ABC case where all the colors are different, A, B, C, I hope everyone can see that it doesn't matter how I label, like it doesn't matter where I put the colors. So for example, if I put C here, A here, and B here, there's always a way to rotate and flip the triangle to get the other ordering of colors. So in this particular case, all I've done is rotate the triangle 1/3 of a revolution. I guess if you want, you can guess and check that all the different labelings can be achieved by rotating and flipping the triangle. Okay, so, and similarly here, it doesn't matter where I place the colors, you can just rotate the triangle until the different color is on that side. So to get from B, B, A to A, B, B, you just rotate it until A is there. So at this point, we've split it up into 3 different cases, and it only remains to count how many possibilities are in the 3 cases. Okay, so I guess, yeah, this is a good point. The question is exactly the same as how many 3-digit numbers can you make using 5 numbers? But you can't recount. Okay, I mean, there are different ways to formulate this question. And often questions do end up being the same. But for now, let's just stick to the colors so as to not confuse people. Really sorry for rubbing this out, but yes, it's true that you can look at it in different ways. Okay, so for the first case, this is the case where all colors are the same. So we've got the configuration AAA. There are 5 possibilities within case 1 because there's only 5 colors to choose from. So this is just, yeah, basically 5, choose 1. Okay. Okay, so yeah, the first case has 5 possibilities. The second case has, you would be tempted to say 5, choose 2, right? Because you want to choose the colors. But there's a little bit of a catch. You can choose 2 colors, but if I swap A and B, so if I choose red and blue, for example, and then I make blue the one that has 2 sticks, or if I make red the one that has 2 sticks, these are 2 different possibilities, right? So once I've chosen the 2 colors, I also have to multiply by 2. And so, I mean, we can calculate that. It becomes 5 factorial on 3 factorial, 2 factorial times 2. And then you just get rid of the 2's because the 2 factorial and the 2 cancel out, and it becomes 5 times 4, which is 20. I also want to quickly point out that this formula here, 5 factorial and 3 factorial, is this thing which we call like an ordered selection. So instead of C, it's 5p2. And this P stands for permutation to basically denote the fact that it's an ordered selection. So in this case, the order in which I select blue and red matters, because if I say blue is the one that occurs twice, or if I say red is the one that occurs twice, those are different. And so we can consider it as an ordered selection where the first slot is the color that appears twice, and the second slot is the color that appears once. So a different way to count this up is just, I've got 5 choices for the color that occurs twice, and then I've got 4 choices left for the color that occurs once. And so that's another easy way to get 5 times 4. Anyway, so for the last one, maybe people can guess. Yeah, so Summer said for case 2, you could just do 5 by 4 because 5 different colors and you only use 2. Yeah, exactly. So I think for a lot of people, it's probably easier to think of it in this way. So for the third case, 5 choose 3 is what I'm seeing is coming out. And 5 choose 3 is the answer. So yeah, 5 choose 3 and 5 choose 2 happen to be the same, but let's just calculate it for everyone. Sorry, I'm going to erase this so that it doesn't get confusing. Yeah, so it's just 5 factorial on 3 factorial by 2 factorial. That's the formula for 5 choose 3. And this ends up being 5 times 4 divided by 2, which is just 10. And unlike the previous case where 2 colors are the same and 1 color is different, all of the colors play the same role. They all occur one time. So it's no longer an ordered selection. It doesn't matter if I choose red first and then green and then yellow, because they all occur once. Yeah, I guess it's a bit hard to say it in a way that, yeah, okay. Yeah, unlike the previous case, the colors all play the same role. And so there's no need to multiply by 2. That's the main idea I wanted to get across here. So it's just 10. Okay, so basically we've broken it down into 3 different cases that are disjoint. And we've added up the possibilities that lie in each case. And then the final answer is just taken by adding up all the possibilities for each case. And we get 5 plus 20 plus 10, which gives us 35. Yeah, I hope that made sense to everyone. Any questions? Okay, no questions. Great. Cool. Now let's quickly move on. I'm going to stop recording.